Hello everyone, we are going to talk today about the natural base exponential function and also its inverse, which is the natural logarithmic function. So just talking a little bit about table of values, graphing, and also algebraically how to determine the inverse of this. Okay, so we have our natural base exponential here, which is f of x is equal to e to the power of x. Okay, no transformations here, it's just that base function. Okay, and I've got a table of values here that I could have been more specific, but really with this graph right here, this is as precise as I can get. So I wrote down the table of values to one decimal place. Okay, so -2, if we put -2 in for x, e to the power of -2 is approximately equal to 0.1. I place that point on the graph over here. -1, e to the -1 is like 1 over e, so that's approximately 0.4, and there's that point. 0, 1, because if x is 0, e to the 0, anything to the power of 0 is 1, so there's that point, the y-intercept. E to the 1, e to the power of 1 is 2.7, we know more than that, we know 2.718, but to one decimal place, 2.7. And e squared is approximately 7.4. So I've got all of those points on here with a scale on this graph of 1 grid mark is 1 unit at both the x and the y scale. Okay, so let's talk about graphically with the table of values what happens if we find the inverse of this function. So the inverse of this function means that we're going to be switching the x's and the y's, and I'm going to call the y the inverse here. Over here, I called the y the original function. Okay, so this means that the point -2, 0.1 is going to turn into 0.1, -2. So we can put that point on our graph, 0.1, -2. 0.4, -1. Okay, so 0.4, -1. 1, 0. So there's an x-intercept here, 1, 0. 2.71, 2.71, and 7.42. And I might not have left enough room here. So 1, 2, 3, 4, 5, 6, 7.4, and 2. There it is there. Okay, so here's this graph. I'll try to draw a nice smooth curve on there. And notice I've put arrows on both ends of both the blue exponential graph and its inverse, the green graph, because I did not restrict any domains. All right, so this is what that graph would look like. Okay, so graphically, we can see what it looks like. Now let's figure out what is the equation of that. So we start with our original. And just as a reminder, this inverse functions are reflections of each other in the line y equals x, in that diagonal line. So that diagonal line is a mirror line between these two graphs. So if we folded here, they would reflect each other. Okay, and that's because of the idea of switching the x's and the y's. So let's start with our original function and find this function algebraically. We've got f of x equals e to the power of x. Let's then change our f of x into a y. Okay, and now I'm going to do the inversing. So I'm going to switch it. Inverse means algebraically all the x's become y's, all the y's become x's. All right, so now it's going to be my other function. X equals e to the power of y. Okay, well, we know that functions are written in the form y equals. Okay, we need to rearrange this so we have y equals. So the way we can do that, this is an e, I'm going to fix that up there. That's e to the power of y. Okay, so we can rearrange from this exponent statement to a log statement, where we would say log base e of x is equal to y. Okay, now this is not proper notation. We actually use proper notation instead. And proper notation for log base e is actually ln, so that's ln x equals y. Okay, we want to have it in this order, y equals ln x. And now let's notate our proper notation. We're talking about an inverse here. So that, and we started with f of x, so our inverse notation is to use f inverse. And so this green graph is the graph of the inverse function of the natural base, and this is the natural logarithmic function, its inverse. If we started with a logarithmic function and wanted to find its inverse, we could do this process backwards. Okay, we would be starting with this function, switch the x's and y's, rearrange into an exponent function, we'd end up with e to the power of x. So e to the power of x and ln x are inverse functions of each other.